Observe this. Now we are supposed to solve the system of non-homogeneous linear equations. So why are they non-homogeneous? First of all, if you observe it, there are certain terms in the equations which doesn't have any combination of variables. This one, the degree of this one is 0, degree of this one is 0, degree of this one is 0, all the others are of degree 1. Earlier in the homogeneous case, degree of every term was 1, that is why they are linear homogeneous equations, and here it is linear non-homogeneous equations because of this constant. Earlier we are able to write the equations in the form of ax equal to 0, where a equal to quotient matrix and 0 equal to 0 matrix. But here what we will try to do is, we will try to write it in the form of ax equal to b, where a is quotient matrix and b is that constants. Those constants I am going to put them here, right? So one more thing you have to be careful here is, after writing the quotient matrix is straightforward anyway. See this, 2x means 2 here, 6y means 6 here, there is no z term, so 0, and 6x means 6 here, 20y means 20 and minus 6z, and there is no x, therefore 0, and 6x, 6y and then minus 18z. Now if we observe the other constants, we have 3 constants and all the 3 are to the left side. So always get the constants to the right side and then put them here. If I get it here, it will be minus 11. If I get it here, minus 3. If I get it here, minus 1. That is why you write here. Now after that, what you should try to do is, using this element, okay, what is the process that I am following here is, I want to convert ax equal to b form, in fact this matrix A, into echelon form. Earlier when we are applying the transformations, we never worried about the B matrix because it was all zeros. But now when you are trying to transform A matrix, whatever row operations you are applying on A, you are even supposed to apply the this one on B also. Let's call this B. I have written this in the form of Ax equal to B. Just try to observe this. Earlier we applied row transformations only to the matrix A to get the echelon form, right? But here we are even supposed to apply whatever operations you are applying on A, you are even supposed to apply the same operations simultaneously on B as well. What must be the reason? Earlier also you are supposed to apply them, but then this B matrix was 0. So even if you apply row operations on a 0 matrix, again you get the 0 only, isn't it? So that is why earlier it didn't matter, but now you should do that, right? So I am going to simultaneously apply the row operations on both of them to make this one into echelon form. Why am I doing all this? By the end of it you will know, okay? Now see this, first to convert it into echelon form, I'll use this element and I'll try to make these two elements as zeros. So how can I make it? You can multiply the first row with 3 and subtract it from row 2 and write the result there, done. And next one is, I'll try to use this element and I'll try to make all these elements as zeros. For that reason, multiply row 2 with 3 and subtract it from row 3. Then what do I get? This one. Now observe the equations that I finally got. And one more thing, whenever you are trying to apply this, we have even simultaneously applied the operations on B as well. See, in this case, we multiplied row 2 with 3 and subtracted it from row 3, which means even this element is multiplied with 3, which means minus 33, and subtracted from this element, which means minus 3. Then what did we get? 30. Got it? And also here, when we multiplied this one with 3 and subtracted from here, which means we multiplied this one with 3 and got 90, and we subtracted 90 from minus 1, that is why I got minus 91. Got it? So this is what I did in order to get this matrix A into echelon form. Now it is in echelon form, isn't it? Now I told you that if you take a system of equations and apply these row operations, and whenever you get the final result or whenever you get the transformed matrix equation, the effective system that didn't change, this system of equations and this system of equations, both of them are equivalent. Whatever are the solutions for this are going to be solutions for that. That is what we have been doing, isn't it? Which means now solving these equations is also equivalent to solving these equations. Now let's see what are the resultant equations we got. Okay, observe this. Now I am just writing this again in the form of equations. Now this row will be multiplied with this column first, and we get one equation and we equate it to -1, and again this row will be multiplied with this column and we get one expression and we equate it to 30, and again this row will be multiplied with this column, we get one expression and equate it to -91. That is what is the process. Now see this, if I multiply this row with this one, what do we get? 2x plus 6y equal to -11. This one is multiplied with this one and equated to -11. And observe the next one, 2x, I think 2y, 0 into x, 2 into y, minus 6z equal to 30. Fine. Observe the last one, it is really interesting. 0, 0, 0 multiplied with x, y, z. So we get some corresponding elements to be 0, 0, 0, which means 0 plus 0 plus 0 equal to 0, and 0 is equal to -91. Observe this. Is it possible? It is not possible. So why do you think that we got this? Because the underlying equations, these are the underlying equations for this one, right? The underlying system of equations are non-consistent. So what does it mean? The underlying given equations must be something like this. See this, x plus y equal to, let's say 10. I'm just taking an example of what we have already seen, and let's say one more thing is x plus y equal to 5. If I write this one in form of a matrix, then what do we get? 1 1 1 1 x y equal to 5 10. Now convert it into echelon form, subtract this row 1 from row 2, then what do we get here? 1 1 0 0, right? And x y, and what do we get here? 5 and then 5, row 1 minus row 2. Now if you try to write it, it will be x plus y equal to 5, and the second one will be 0 equal to 5, isn't it? So whenever we have such inconsistent equations, I think you know these two equations are inconsistent, you figured it out, right? Otherwise just observe this. This equation is saying that sum of x plus y has to be 10, and this equation is saying that sum of x plus y has to be 5. If you find out the values of x and y in such a way that the sum turns out to be 10, it can never be 5, which means there is no solution which can simultaneously satisfy these two equations. In such a case, when you apply the transformations, we get such inconsistencies. So whenever you get this, you can observe that even though these equations doesn't look like they are having inconsistent equations like this, but once you apply the transformations, they are clearly visible. Got it? Therefore, you can say that whenever you get such a case, we can say that the equations are non-consistent. Now, when I am saying that these are non-consistent, I don't want to do this method all the time. I'll try to apply the working rule. What is the working rule? If you observe it, if you remember it, the working rule was this. The working rule was augment A with matrix B. This is A and this is B, and then convert this one into echelon form. And once you convert it into echelon form, you try to find out the ranks of both the matrices, ranks of A, B as well as ranks of A. And if these two are not equal, then we can say that the equations are non-consistent, right? So even by this method also, we should be able to say that it is non-consistent. From now on, I'll be using this method. So let me show you this example using this method. So how can we do that? See this. What they wanted to say is AB, concatenate A with B, which means 2, 6, 0, 6, 20, minus 6, 0, 6, minus 18 is now augmented, that is called augmentation, is now augmented with minus 11, minus 3, minus 1. I am just writing these dots just to show you that this is A, this is B, and the combination is AB. Now you try to treat this as a single matrix, and again you convert it into echelon form by using the same transformations. Then see what happens. Now I'll be applying the same transformations. R2 is R2 minus 3R1. Then what did we get? We got 2, 6, 3 minus 11. Row 1 doesn't change, but row 2 will change, and row 3 will not change. Okay, and again apply the next transformation, which means R3 is R3 minus 3 into R2. Okay, then what do we get? 2, 6, 3 minus 11, 0, 2 minus 6. I think this one is 3, right? This one has to be 3. Anyway, it doesn't make, or I think it is 0 only. Here it is 0. Here I changed it. Okay. Fine. So minus 1130, 0, 0, 0, minus 91. Observe this. Okay. So now if you observe this one, these are dots. So this is A and this is AB, right? So if you observe this one, the rank of the matrix A is equal to number of non-zero rows, which is nothing but 2. The rank of the matrix AB is equal to number of non-zero rows, which is nothing but 3. Therefore, we can say that they are inconsistent. So now I think you understood. It is same. It is actually same. Either you write them like this and then go on applying the row transformations, or you augment them and then go on applying the row transformations. Both are actually one and the same. There is no much difference. Writing like this will be convenient because you need not write this XYZ terms. And even you can get the final equations, the resulting equations from this AB matrix as well, right? So that is why either you do that or by this method, the final answer is going to be same depending on the ranks of A, B and A. So this is an example for which it is inconsistent.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.